Welcome everyone to the EasyPower Tuesday Refresher. My name is Jim Chastain, and frequently the question arises, how mandatory is the need for an arc flash risk assessment? Invariably, the question comes in two forms. First, there's a contractor or consulting firm who's getting pushback from a client who says, show me the OSHA regulations that say I need to have an arc flash study done. Well, this is the answer. It's primarily a logical argument that precipitates from the reading of the OSHA General Duty Clause, which is Section 5A1 of the Occupational Safety and Health Act of 1970. Employers are required to provide their employees with a place of employment that's free from recognized hazards that are causing or likely to cause death or serious harm. So combined with the definition of arc flash as a recognized hazard likely to cause serious injury, I'm not going to spend any more time on this section. So the second way I hear the question is usually in discussion with contractors or facility maintenance teams, and it usually results in a misunderstanding or due to a misunderstanding of overlapping standards in the area of electrical safety. Well, this is a group of people where you will find the highest concentration of qualified workers when it comes to most things electrical. And these are the people that are most at risk when it comes to arc flash hazards. So I'm particularly interested in making sure that we are on the same page with them. So the answer to how mandatory is arc flash risk assessment should not be fuzzy for this section of the population. So frequently I'll hear the comment either in a workshop or online that if it's not in the code, I'm not going to worry about arc flash. Or another way of kind of responding is, well, our state has not approved NFPA 70E, so we do not have to comply with arc flash yet. Well, both of these statements or comments reflect some misunderstanding, and let me kind of touch on this briefly. NFPA 70 is what's regarded or usually referred to as the National Electric Code, and it's enforced by a series of checks and balances, including permitting, inspections, and approval by certain designated authorities. And so yes, it is regionally adopted, and it does have certain passages or certain articles that can be considered grandfathered, but it's not, in the past, has not had all that much bearing on arc flash. To confuse the issue, the standard for electrical safety in the workplace is labeled NFPA 70E, and it's effective at the time it's released. It's not subject to local approval, and it's frequently cited by OSHA when fines are assessed, usually after an event or a problem has been recognized due to employees being hurt or sent to the hospital. So now this confusion is not an issue on new construction, since most often the scope of work for new construction or additional construction on existing systems will include the verbiage requiring compliance with NFPA 70E. And so in that case, it'll be up to the project manager to ensure his checklist includes arc flash as part of that discussion. The real gap is whether a study is required on existing systems. So that's kind of where I'm going with this. Both documents are updated on a staggered 3-year system, a 3-year cycle. The specific references in 2017 version of NFPA 70 have some specific references to arc flash, and that's where I'm taking this discussion. And the bottom line is, because now there's more specific information on arc flash in the National Electric Code, does that make arc flash compliance more mandatory? Well, I'm going to run through real quick progression here of the list of articles, the new articles that have been added, not all of which have direct reference to arc flash, but it's interesting in reviewing the list because there's a lot of emphasis on alternative energy installations, and just by coincidence, here in 2 weeks we will be doing a presentation on DC and hybrid systems, and specifically the arc flash implications. So don't want to spend a lot of time on these other than just by acclamation. These are part of the changes in the 2017 version. Just a side note, NFPA 70E does not include domestic settings, but the NEC has included the requirement to use arc current sensitive breakers for several years now in domestic settings. A sign of the times we can see is coming up when garage wiring is an area of focus as much apparently for electric vehicles. And then you wonder why meeting rooms are now included, as far as the number of outlets are now included in the code. And not that it has anything to do with arc flash, but certainly it has to do with a lot of other variables having to do with portable computers. So this brings me to the new additions that specifically address arc flash. The first is Article 110.16b, and for starters, it suggests that an arc flash label may already be in place. So its criteria is if a label, acceptable arc flash label, is not in place, then on service equipment rated for 1200 amps or greater, other than dwelling units, there must be a label that indicates nominal system voltage, available fault current, clearing time of overcurrent protective devices based on available fault current, and the date applied. So if we were, and it turns out I was working on this hybrid example for the refresher here in a couple weeks, and so I wanted to compare what the results from that project would produce if we had to produce a label for the switchgear. So here's what we're showing. So we need to show the date the label was applied, the nominal system voltage, in this case it was 600 volts, the available fault current, in this case it was 10,000 amps, and the overcurrent clearing time was indicated at just over half a second, to be more specific. Now this again is not required if there's an arc flash label there, which means there's already been a study. If we run these values through EasyPower, we see that we calculate just over, looks like it's 12 calories per square centimeter. And what I want to do is take these same values. So the alternative in NFPA 70E, the alternative to labeling or deciding what PPE we need, we're given two options. One is calculating incident energy, which I've just done and showed. The other is, if we have not done a study, the PPE selection is through a PPE lookup table. So again, this is only applied if we have not calculated incident energy. So that's why we're going through this exercise. Now, I'm not an expert at using the lookup table, but let's kind of walk through this together. According to 130.7c, if we start from the top of the table and we look down here at AC systems, if we're going to work on energized electrical conductors and circuit parts, including voltage testing, then according to 137.c, we need to have PPE. All right, so that's the first step in determining PPE. We slide farther down in the table and we find, if we're looking at 600 volt class switchgear with the power circuit breakers or fuse switches and a maximum of 35,000 amps short circuit current with a maximum of half a second fault clearing time, then the requirement is to use PPE 4 from these categories. So far, so good. If we go to the final page of this lookup table, we see that category 4, and again, it's PPE category. Don't even get this confused with HRC category. So PPE category 4 means that we have to have PPE rated to 40 calories, and it needs to cover these elements in our dress down or our layers. Now, bear in mind that we can only use this table if we can verify the equipment's been properly installed, that it's been properly maintained, and it's not showing any evidence of pending malfunction. So what's the bottom line? Even if the business owner does not want to pay for an arc flash study, even work on his system to be de-energized would require us to put on PPE rated for 40 calories just to be able to test the voltage on the switchgear to make sure the voltage has been removed. Well, you might say, Jim, if we know the energy will be less if we work on something farther down the line on the one-line diagram. Well, my next question might be, how accurate is this one-line diagram if he really hasn't done an arc flash study? So let's set that aside for a second. So this alone, granted, this paragraph or this article alone does not make arc flash official, but I would maintain to any qualified worker it should drive home a heightened need to help educate the employer about the risks and the liabilities involved if he has a system in this range. And this is not even all that big of a system. Now, for new construction, panels are required, according to Article 408.3, to have a barrier on the line side termination to prevent accidental contact. And so the question is, does this help with arc flash? Well, the most common initiating event causing arc flash is incidental contact, often while removing panel covers. But the guideline to exclude the main breaker panel in a panel is really a function of the potential size of the plasma ball. I've had people respond that, well, we don't really need to worry about this main breaker isolation thing now that we have this barrier. And again, I think this shows a little bit of a misunderstanding of what's going on in arc flash calculations. So in EasyPower, we have a reference or a control that excludes the main breaker in the panel, and it's really a function not so much of whether the panel can do the breaker can do its job. It's more a function of the size of the plasma ball and potentially whether or not it can engulf the main breaker, which would allow the arc to jump the breaker and effectively negate the potential protective values of the breaker itself. So let me jump into EasyPower. And frequently this is an area that's not well understood. We're not too worried about the main breaker not working unless we have doubts about how well it's been maintained. The issue is, if an arc initiates in the panel, will the potential plasma ball engulf the main and sustain the arc in spite of the main breaker tripping? So here's an excerpt from our website. There's a video on the website, Arc Flash resource page, that shows before, during, and after an arcing event that was captured on a video security camera. And I frequently blow up this, or expand this middle image in the presentations to talk about some very key elements of an arc flash itself. So first of all, if you notice this kind of circular area on at the bottom of the cabinet, let me kind of go back. What we're talking about is a situation where 3 people were standing clearly within the arc flash boundary without adequate PPE, and we can see that this door is potentially closed to the back of one individual, and so the picture we're looking at is going to include the effects of that door shielding the radiation or the explosion. So again, the circular area is the fireball, and you can see quite easily it's probably 6 to 8 feet in diameter, and all 3 individuals standing inside these doors are engulfed in that fireball. It's worthy of note that there's an area here at the top of the cabinet which extends beyond the circular area. This is actually reflected energy from the back of the cabinet because this is a closed box, and it's amplifying the energy that these people are being exposed to, especially the people that are standing up. Now, because this is an arcing event, at the heart of this fireball is a plasma ball, And just by the general physics of the way this works, I think the estimates were this was between an 8 to a 12 calorie explosion, that the plasma ball more than likely is somewhere between 3 and 6 inches in diameter, and that's what's producing this amount of energy release. So the question I have of my data collection folks is, if that plasma ball is located in the area of the main breaker, will the main breaker do its job? So I repeat, this plastic barrier, does it really improve the arc flash situation? And again, I direct that question to the people doing data collection, because they're the ones that have to make this assertion about the main breaker should be included or excluded. Okay, so this alone doesn't make anything official about arc flash. So let's go to the last article here that I've picked out that specifically addresses arc flash energy reduction. So Article 240.87 actually existed, and it had several areas specifically for greater than 1200 amp circuits that there must be energy reduction methods from one of the following areas. The areas that existed were zone selective interlocking, differential relaying, maintenance mode, or active arc flash mitigation. Well, now with 2017 version of NFPA 70, the requirement to add arc energy reduction methods in the circuit breaker in the form of instantaneous trips settings that must be less than the available arcing current is very specific, and unlike existing methods that were already on the list, these requirements have performance considerations to make sure that it's meeting that it will be able to protect us against the tripping point of the arcing current. So I'd like to emphasize that the only way to ensure, again, these changes are now in effect for the NEC with the release of 2017 version. And the question is, does this make arc flash studies a requirement or more mandatory? And my point here is that, and emphasize that the only way to ensure that this requirement is met is to calculate what the arcing current will be, verify the device will function as needed at the place installed in the circuit. Again, that's part of equipment duty verification when you do a study. So this is, pardon the expression, the smoking gun that says, yep, according to the National Electric Code, an arc study needs to be done on every system that has, in this case, available 1200 amps of service, or rated at 1200 amps. So I'd like to emphasize that the only way to meet this requirement is to do these calculations, and if it was not specifically called out by the NEC before, this seems to make it pretty straightforward in black and white. So I can get down off my soapbox. Thank you for joining us today. Apologize, we'll not be able to take questions online, but if you will, please, anything that's submitted on the question box or sent to EasyPower, you can address an email to jim@easypower.com, and we'll respond via email. I do encourage you to check in with the website because there's been new regional training scheduled, and by all means, those of you that would like to do so, please follow us on social media and stay current on announcements and updates. Have a great rest of the week.